Hello everyone, today we will discuss some of the mathematical methods and its steps briefly. Firstly, start with Cardan's method. In this method, firstly we have to remove the x squared term. If it is already removed in a question, we must proceed to the next step. Let us assume the solution in the form of y equal to u plus v. Then we have to use the identity u plus v whole cube. Then we have to substitute the value of u plus v as y. Then it forms a quadratic equation for u cube and v cube. Then we have to solve the quadratic equation to find u cube and v cube. Then we have to take the cube roots to get u and v. Then we must solve for y equal to u plus v. Then we have to back substitute to find the value of x to find the roots. In case of Euler's method, firstly, the equation should not have the x cube term. Then we have to substitute x equal to root p plus root cube plus root r, as you let us assume that. Then use different identities to compare with the given equation. Then using relation between roots and coefficient, we have to solve the cubic equation. Then lastly, we have to find the value of root p, root q and root r. Then solve for x equal to root p plus root q plus root r and then find the roots. Then we will see about the transformation of equation. Transformation of equation actually means the changing of variables on equation using some given assigned relation to obtain a new simple form. Firstly, we have to identify the given transformation in the question. Then we have to substitute the given relation into the equation. Then we have to simplify the resulting equation and then write the equation in standard form. If the relation is about roots, convert root changes into an equivalent variable transformation. Then we will see about metric inversion. In metric inversion, we have to write the system as ax equal to b, and then we have to calculate the A inverse by identifying the determinant and adjoint. Then multiply the inverse matrix with b and finally write the final solution. Now we will see about the echelon form and raw reduced echelon form, RREP in short. In case of echelon form, first we have to write the augmented matrix and apply operations to make a pivot, that is the leading element. Then we have to make all entries below each pivot 0. Then we have to move to the next row and then repeat the same steps. Then we have to stop when the matrix becomes triangular, that is the echelon form. Then we have to use the back substitution to find the solution or count non-zeros for rank. In case of raw reduced echelon form, it is a more advanced form of echelon form. Same in case of echelon form, we have to write the augmented matrix, then make the first pivot 1, then we have to make all entries below and above the pivot 0. Then we have to move to the next row and then repeat the same steps. Then we have to continue until all pivot columns having only a single one and all other entries as 0. Then we have to read the final solution from the raw reduced echelon form of matrix. Now we will see the method Descartes' rules of signs. In this method, we have to first arrange the polynomial fx in the descending powers. Now we have to count sign changes in fx, which gives possible positive roots. Then we have to find f of minus x. Then we have to count sign changes in f of minus x, which give possible negative roots. Now the possible roots are number of sign changes or less by an even number. Now we will see the de Moivre's theorem. In this theorem, we have to first convert the complex number to a polar form, that is r into cos theta plus I sin theta. Now we have to apply de Moivre's theorem, that is z to the power n equal to r to the power n bracket cos n theta plus I sin n theta. Then we have to convert back to Cartesian form. For roots, we have to use z 1 by n equal to r 1 by n cos theta plus 2k pi divided by n plus I sin theta plus 2k pi divided by n, where k belongs to an integer. Now we will see the exponential function and logarithm function of a complex number. In case of exponential function, we have to first write the complex number as x plus iy. Then we have to use e to the power x plus iy is equal to ex into cos y plus I sin y. In case of logarithmic function, we have to first convert z equal to x plus iy to polar form. Then we have to find r, z modulus, and theta, which is equal to argument of z. Then we have to use log z equal to ln r plus I into theta plus 2n pi, where n belongs to z, which is an integer. Thank you everyone for your time during this brief session.